How are you everybody? How are you today? This is the course of Advanced Mathematics for the 4th year Statistic English section in Banya University 2020. This is the second lecture in our course called Advanced Mathematics, Advanced Topics in Mathematics. Now, we will start our lecture by Arithmetic Series. What is the meaning of Arithmetic Series? This is a continuation of the last lecture sequence and series. Arithmetic Series, the numbers of sets in the rows in the amphitheater for an arithmetic sequence. To find the number of people who could sit in the first 4 rows, add the first 4 terms of the sequence. The sum is 8 plus 22 plus 26 plus 30 or 96. A series is an indicated sum of the terms of a sequence. Since 18, 22, 26, 30 is an arithmetic sequence. 18 plus 22 plus 26 plus 30 is an arithmetic series. Below are some more arithmetic sequence and the corresponding arithmetic series. Arithmetic sequence, as we show, and arithmetic series, every term in arithmetic sequence must be added to P arithmetic series. Study tip: the sum of a series is the result when the term of the series are added. An indicated sum is expression that illustrates the series, which includes the terms plus or minus, so that the series include the terms plus or minus. N represent the sum of the first n terms of series. For example, S4 is the sum of the first 4 terms. To develop a formula for the sum of any arithmetic series, consider the series below. S9 equal 4 plus 11 plus 18 plus 25 plus 32 plus 39 plus 46 plus 53 plus 60. Write S9 in 2 different order and add the 2 equations. S9 plus. Okay. This is all what we mean about arithmetic series and the summation. The formula Sn equal n1 plus n2 represent the sum of an arithmetic series, so that you must know the sum of an arithmetic series and the shape of an arithmetic series, so that arithmetic sequence term added to each other or subtracted from each other called arithmetic series. Also, example number 2, find the first term. This is also an illustrative example, a second illustrative example about the arithmetic series. You can solve also by the first rule or the second rule stated in the previous slide, but you must determine A and the difference and N, and you can make a direct substitution to find the result, to find what we want about the sum, or what we want from the sum of an arithmetic series. This is an easy example like the first example, example number 1, and this is a direct substitution and a direct application about the 2 formula or 2 mathematical rule about the sum of the arithmetic series. Also, example number 2, find the first term. This is also an illustrative example, a second illustrative example about the arithmetic series. You can solve also by the first rule or the second rule stated in the previous slide, but you must determine A and the difference and N, and you can make a direct substitution to find the result, to find what we want about the sum, or what we want from the sum of an arithmetic series. This is an easy example like the first example, example number 1, and this is a direct substitution and a direct application about the two formula or two mathematical rule about the sum of the arithmetic series. Sometimes it's necessary to use both a sum formula and the formula for the nth term to solve the problem. Find the first three terms. This is a third example related also to the arithmetic series summation, the sum of the arithmetic series. Find the first three terms of an arithmetic series in which a1 equal 9, an equal 105, and sn equal 741. Step 1, since you have a givens a1, an, and sn, you can use sn over 2 a1 plus an, and we want to find n. Step 2, find d, 8 equal d. This is the first step, and this can use to determine a1 and a2 and a3. a2 equal 9 plus 8 or 17, a3 equal 17 plus 8 or 25. The first three terms are 9, 17 and 25. This is another example and another thinking about the sum of an arithmetic series. It's an easy example, but you must understand what you are required to find the givens, and you must determine your requirement and the rule you want to use to find the solution. This is section related to sigma notation. Writing out a series can be time consuming and lengthy. Writing out the series may take more time and length. For convenience, there is a more concise notation called sigma notation, or convenience notation called sigma notation. The series 3, 6, 9 plus 12 plus up to 30 can be expressed as summation in from 1 up to 10, 3, n. This is called sigma notation. The variable in this case n is called the index summation. This is a detailed explanation about sigma notation. If every student does not know any information or data about sigma notation, this is a detailed about sigma notation. To generate the term of a series given in sigma notation, successfully replace the index of summation with consecutive integers between the first and last values of the index, inclusive. For the series above, the values of n are 1, 2, 3, and so on up to through 10. Now evaluate a sum in sigma notation. This is an example to evaluate a summation of sigma notation, a summation of an arithmetic series. Evaluate summation g from 5 to 8, 3g minus 4. Method 1, find the term by replacing g with 5, 6, 7, and 8, then add it. Method 2, since the sum is an arithmetic series, use formula s sub n equal n over 2 multiplied by a1 plus an. The sum of the series is 62. The sum of the series is 62. You can use the sum and sequence feature on graphing calculator to find the sum of a series. This is a direct example about sigma notation and how we can make a summation about the arithmetic series. Sum of series. The calculator screen shows the evaluation of. This is think and discussion. Explain why you can use on any letter for the index summation. This is a thinking about the calculator. You can use calculator to find the sigma notation of a series. Check for understanding. Concept check. Explain the difference between a sequence and a series. This is very important. Open-ended. Write an arithmetic series for which S3 equal 10. Open-ended. Write a series 7, 10, 13, 16. using sigma notation. That practice files is in for each arithmetic series described. Application, word cultures. This is an direct application to understand, to make a practice, to make application how you can find the summarization about sequence and series, sigma notation, arithmetic series, the summation of arithmetic series by the two methods we described in this lecture, in the previous lecture, so that you must do all this application to understand and check your understanding about the series, the sequence, the arithmetic series, how we can make an arithmetic series with the two mathematical formula, how we can do the sigma notation about the arithmetic sequence and the arithmetic series. Practice and apply. This is all for you as a student to solve. This is an exercises you must solve to make more and more and more understanding. More practice resulted in more understanding about the arithmetic series, about arithmetic sequence, about the series itself, about the sequence itself, about the sigma notation, about the summation of an arithmetic series and sequence and series. This is application related to arithmetic series, and you must solve to check also your understanding for arithmetic series and arithmetic sequence and the some sigma notation related to arithmetic series and sequence. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.